Alien life and the Fermi Paradox. The Great Filter. Are we doomed? The universe is enormous and ancient. With hundreds of billions of galaxies, each with hundreds of billions of stars, the numbers suggest we should be swimming in alien civilizations. So the question famously asked by Enrico Fermi is, where is everybody? One terrifying answer is the Great Filter hypothesis. This suggests that there is at least one barrier, one incredibly difficult step, that prevents life from progressing to a visible spacefaring stage. The critical and frightening question is, where is this filter? Is it behind us? Was the jump from simple prokaryotic cells to complex eukaryotic life a 1 in a billion fluke? If so, we are miraculously rare, and the future is open. Or, is the filter still ahead of us? Is it the development of self-destructive technology like nuclear weapons, or climate change, or a future technology like runaway nanotechnology, or artificial intelligence that inevitably destroys its creators? If the filter is ahead of us, then our silence is a grim omen. It means that almost every civilization that reaches our stage of development soon vanishes. Our continued existence may depend on which side of the filter we are on. Life, but not as we know it. Our search for life is hopelessly biased. We look for planets with liquid water, a carbon-based chemistry, and an atmosphere like our own. But what if life exists in forms we can't even conceive? On Saturn's moon Titan, with its rivers and lakes of liquid methane and ethane, life could use methane as a solvent instead of water. Its biology would be fundamentally alien. Or consider silicon-based life. Silicon is right below carbon on the periodic table and can form similar complex structures. On a hot, high-pressure world, silicon-based organisms might have metabolism rates thousands of times slower than ours. We might not even recognize them as being alive. Or what about life existing in the plasma atmospheres of stars, as self-organizing magnetic structures? Or life based on the nuclear strong force inside neutron stars, as hypothesized by Frank Drake. The problem with finding aliens might be that we're looking for a reflection of ourselves, when the reality could be so much stranger. The dark forest universe. Why is the universe so silent? The dark forest hypothesis offers a chillingly logical answer. It imagines the cosmos as a dark forest, filled with hidden hunters. Every civilization is a hunter, hiding in the trees. They know the forest is full of others, but they also know that any other hunter they encounter could be infinitely more advanced and powerful. To reveal your location, to make a sound by broadcasting signals, is to risk instant annihilation from a civilization that sees you as a potential threat. The safest strategy for survival is absolute silence. Stay hidden. Listen, but never speak. In this terrifying model, the universe isn't empty. It's crowded, but paralyzed by mutual fear. Our efforts with SETI to listen for signals might be safe, but our own broadcasts, like the Arecibo message, could be like a child shouting in that dark forest, unaware of the predators listening in the shadows. We are the ancient ones. What if the silence is simply because we are the first? For the first several billion years after the Big Bang, the universe was a hostile place. It was filled with lethal gamma-ray bursts from dying stars, and it lacked the heavy elements necessary to form rocky planets. The universe had to mature. It had to be seeded with enough carbon, oxygen, and iron from generations of supernovae to allow for the formation of Earth-like worlds. Perhaps the window for complex life only opened relatively recently on a cosmic timescale. We could be the pioneers. The first flicker of biological consciousness in a galaxy, a universe, that is only just becoming habitable. In this scenario, the silence is not ominous, it's expectant. We are the ancient ones, the firstborn. The responsibility to spread life, or at least to understand it, may fall entirely on us. The alien megastructure mystery. In 2015, astronomers spotted a star behaving in a way that defied all explanation. Tabby's star, 1/500 light-years away, was dimming in dramatic, irregular, and asymmetric ways, sometimes by as much as 22%. Natural explanations were sought: a colossal swarm of comets, a giant dusty ring system, a planet that had been torn apart. but none of the models fit the data perfectly. This led to a spectacular, if unlikely, hypothesis. What if we were seeing an alien megastructure under construction? A Dyson Sphere, a vast array of energy-collecting satellites designed to harness the entire power output of a star. While most scientists strongly favor a natural, if unusual, dusty explanation, the mystery captured the public's imagination because it was the first time a potential technosignature had been seriously considered. It remains a powerful reminder that as we explore the cosmos, we must be prepared for the utterly unexpected. Is Tabby's star a natural puzzle we haven't solved, or is it our first glimpse of a project on a scale that dwarfs human imagination?